sketch the graph of f of x equals x cubed plus 2x squared minus 8x by using the end behavior, finding the zeros, and explaining the behavior near each zero. And we also have to find a point between each zero. So first, let's find the end behavior. Since the leading term, x cubed, is both positive and cubed, so that's odd, the end behavior of the graph will behave like x cubed. Next we have to find the zeros of this function. So we will set this to 0. We can take out an x from each term. And then we can factor this even further into x plus 4, x minus 2 equals 0. Then we will set each term to 0. This is x equals 0. X plus 4 equals 0, so x would be negative 4. And x minus 2 equals 0, x would be 2. So the zeros of this function are 0, negative 4, and 2.
To all my lost boys, to all my lost boys, we rowdy.
Okay, next we're going to find the behavior near each zero. To do this, you plug in the zeros into the factored form where the term will not equal 0. So near 0, you would plug in the 0, 0. You can multiply 4 times negative 2, negative 8x. And negative 8x acts linear. The next 0 is negative 4. So we will find the behavior near negative 4. You plug in negative 4, giving you negative 4, x plus 4, negative 4 minus 2. You add what's in parentheses first, so negative 4 times x plus 4 times negative 6. Multiply negative 6 by negative 4, you get 24 times x plus 4. Distribute, leaving you with 24x plus 96. And this also acts linear. The behavior near 2, you just do the same thing. We're plugging in 2 into the factored form where x will not equal 0, or the term will not equal 0. So 2 times 2 plus 4, x minus 2. Add what's in parentheses first. 2 times 6, x minus 2. Multiply this out. 2 times 6 is 12 times x minus 2. Distribute, leaving you with 12x minus 24. And this also acts linear.
We rowdy, to all my lost boys, to all my lost boys, we rowdy.
So the last thing we need to find is a point between each zero. To do this, we have to pick a point between the zeros. So let's pick negative 3. You plug negative 3 into x, and the easiest way to do that is back to the factored form. So let's choose the value of negative 3 times negative 3 plus 4 times negative 3 minus 2. Add what's in parentheses first. Negative 3 plus 4 is 1. Negative 3 minus 2 is negative 5. Multiply negative 3 by 1 by negative 5, this gives you 15. So the x, for where x is negative 3, y is 15, this leaves you with a point, negative 3, 15, between the zeros, 0 and negative 4. Next we will find a 0 between negative 4 and 2. So let's pick the x value of 1. Where x is 1, you plug in 1 back into the factored form. So 1 times 1 plus 4 times 1 minus 2. 4 plus 1 is 5. 1 minus 2 is negative 1 times 1. 1 times 5 times negative 1 is negative 5. So where the x value is 1, the y value is negative 5. So we get a point of 1, negative 5 between the zeros of negative 4 and 2.
Shout to all my boss boys, we rally. Shout to all my boss boys.
First I'll graph the zeros at 0, negative 4, and 2. Next I will graph the known points, negative 3, 15, so and 1, negative 5. We know that the ending graph will open up, act linear. We know that it has to go through the origin, knowing that it acts linear near all the points. Go up to negative 3, 15, and then come back down to the 0. So this is the final graph of f of x equals x cubed plus 2x